Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. We are still treating limits of functions. But this time around, we are going to consider indeterminate form. Okay, when you have a limit of a function, when do we say this limit is indeterminate? And when those limits are indeterminate, what are the measures? Do you get it that way? What are the measures? So in this tutorials, we are going to learn and explore. All right. So let's consider this. So when we have lim as x approaches a of f of x all over g of x. We know that this is the same as lim as x approaches a of f of x all over lim as x approaches a of what by g of x. This is true or valid provided the denominator, which is provided that my g of x does not go to what? Does not go to 0. Okay, because when the function goes to 0, then it becomes what? Undefined. Okay, so provided lim as x approaches a of g of x is not equal to 0. Alright, now what does it mean? If the function is undefined, it means that a does not belong, this a, it means this a does not belong to the domain of the function a. Okay, so we say, so this one is what? This one is defined. Let's consider this. When I have lim as s approaches a all over lim of g of x as the same x approaches a, and provided the denominator, provided g of x is equal to a, what happens? So we have this lim of x over lim of g of x. Okay, this is as x approaches a, as x approaches a. It's what? Is undefined or does not exist. Why? Because we said what? The denominator is what? Is equal to 0. Now, what happens if the f of x is equal to 0, and what happens if g of x is equal to 0? So if f of x is equal to g of x, which is equal to 0, what happens? So we have lim of f of x as x approaches a over lim of g of x as x approaches a. So if this is equal to 0 and this is also equal to 0, what does it mean? This one is also what? This is what? Undefined, or does not what? Does not exist this way. Viewers, this is what we call what? Indeterminate form of limit of functions. So when we say a limit is indeterminate, that means it does not what? It does not exist, or it is undefined. So functions of this nature, this is what we call what? Undefined. So this is what? Indeterminate. This is indeterminate what? Indeterminate form. As simple as that. Now, viewers, when you have, let's say for example, if I have this x squared minus 1 all over x squared plus x minus 2. Okay, let's say we have, as x approaches, let me consider 1. Okay, 1. Let's see what happens. X squared, wherever I see x, I put 1. So I have 1 squared minus 1, then all over 1 squared, then plus what? Plus 1 minus 2. What do I have? 1 squared means what? 1, then minus 1, then all over 1 squared means what? 1 plus 1 minus 2. 1 minus 1 is what? 0 over 1 plus 1 is what? 2 minus what? 2. So what do we have? 0 over what? 0. Viewers, this is what? This is indeterminate. As x approaches or as x approaches a, it simply means that a is not a domain of the function f or g. Do you get it that way? So when you have situations like this, what are the measures? So let me give you some tricks or hints to what? To solve what or to clear the doubt whenever you encounter indeterminate form of a limit. So I will call this techniques in solving indeterminate form. So this is techniques. So I have techniques. So techniques in solving indeterminate form. Indeterminate form. Okay. So let's look at some simple identities. So when I have, let's say a squared minus b squared. Okay, these identities, the principle or the theorem we use, you call it what? The factor theorem. So factor theorem is just a theorem in polynomial of what? Or function. That's the name of the theorem. So this is what? Difference of two squares. So this is the same as what? You add them in one bracket, then you what? Then you subtract them in another bracket. Okay. So you add the terms in one bracket, then you subtract the terms in another bracket. This is one identity you should note. The other identity is when you have a to the power, let's say 3 minus then b to the power 3. You can still use what? The factor theorem. So you do the division of the polynomials, then you multiply the divisor by the quotient. So you just get what? That's one way to solve for indeterminate form. But just go straight to the techniques I want to give it to you. So this is just the same as you have a and b, right? So you have a, what do you see here? Minus, then minus b in one bracket. Then you open another bracket or parentheses. What do you have here? You have a, so you square the a, then plus. What do you see here? B, then you square the b also. So you have the b squared over here. And the trick is this. Whenever you start with negative over here, when you come here, it becomes a positive. So this becomes, because there is a negative here, my next operator becomes what? Positive. Then a times b gives what? A what? A, as simple as that. This is the best trick I can give it to you. Alright? So it's just simple. You have your first term, your second term here, do justice over here. You have a minus b. Okay? Then you square this, then you square the last term, then guess what? Multiply the a times b gives what? ab. Whenever you see negative here, when you come here, it becomes what? Positive. Otherwise, you are at liberty to what? To choose other approach. That is what? The division of polynomials, and it's bulky. Okay? So this really saves time. And the last identity, we have a cubed, then plus, then b what? Cubed. you follow the same idea. A and B. What are they doing? Are they not adding? They are adding. So add them. A plus B. Then what do I have here? A squared, right? A squared. Then plus. What do I have here? I have my B squared. This for here. It always be plus plus positive. Okay. Now here the operator here is what? Positive. When I come here, I'll start with what? Negative. That is the rule. Okay. As simple as that. Viewers, incorporate these tricks into memory so that whenever you encounter indeterminate limit function, you can find your way out. Thank you. I'll meet you in the subsequent lecture videos where you are going to appreciate the importance of what? Of these techniques whenever you encounter what? Indeterminate limits of functions. Bye.